So this question's got a picture of some polygons, and when we read the information carefully it talks about a regular octagon, and it just says that this is a hexagon. So we've got an octagon and an hexagon, but they're saying the regular octagon. So as soon as we see a question involving polygons, and we know that's about polygons, we've got octagons and hexagons and so forth, then we should be asking ourselves, if they are regular, then the exterior angle of any regular polygon is equal to 360 degrees divided by n, n being the number of sides. So we've got an exterior angle, which we can think of as this angle here, or it's that angle there, or it's that angle there. An exterior angle is the amount of turn you make to go from one side to follow the other side. So the exterior angles are going to be those ones there. So we can do 360 degrees divided by 8, which tells me that we've got 360 divided by 8, which is 130, no it's not, it's 45. So 45 degrees. Basically when you divide by 8, you halve, halve and halve again. So half of 360 is 180, half of 180 is 90, half of 90 is 45. So we recognise then that this is 45 degrees. Well, if that's 45 degrees, we then now know the interior angle. So we now know the interior angle of a regular polygon is going to be 180, take away the exterior angle. Basically because if that's the exterior, that's the interior, they both are on a straight line, so they meet at a point and add up to 180. So we now know that we do 180 take away 45 degrees, which is 135 degrees. So this is all for the octagon. So for the regular octagon. So we now know if that's 45 degrees, then we know that the whole of this is 135 degrees. The question wants the angle KFE. So when we look at this KFE, then basically we're after this little bit here. So it'd be nice if we knew what this bit here was. Well, they've told us a fact about the two angles here. They've told us they're 140 degrees, and they've told us that JK is a line of symmetry. So if we add on JK, then we can see quite quickly, if that's a line of symmetry, then that is 70 degrees, that is 70 degrees, and because it's made a trapezium, and because these are lines of symmetry, then that line must be the same length as that line must be the same length as that line, and therefore we've got a nice little trapezium going on here, where we've basically got the facts that that's 70, that's 70, these two angles, we'll just call them x for now, are going to be equal. We know the angles inside a four-sided shape add to 360, so we've got 70 degrees plus 70 degrees plus 2x's equals 360 degrees, so we've got 2x is equal to 220 degrees, so x equals 110 degrees. Add 70 and 70, 140, take it away, so we took away 140 degrees, that gave us 220, and then we divided by 2. So we now know that this little bit here is 70 degrees, is 110 degrees, so this is 110 degrees, and this bit here is 110 degrees. So that means the bit we need, this bit here, so basically we're going to say angle KFE is equal to 135 degrees, take away 110 degrees, equals 25 degrees. So basically we saw that fact because we worked out that the interior angle of the octagon was 135 degrees. We've used the line of symmetry to help us decide that the bottom two angles in the hexagon we're 110 degrees, so the bit here must be 135, take away the 110 is going to be 25 degrees, and that's why we found out the final answer is 25 degrees. Okay, so it comes back to rules of polygons really, guys. Angles in polygons, we recognise the for regular shapes, regular polygons it says, then 360 divided by n tells you the exterior angle, and then the interior and the exterior are related by being on a straight line, which means they add up to 180, so I can find the interior angle of the polygon and so forth.